This is Algebra 2, Section 8.3, Parts A and B. Today we're going to be looking at graphing rational functions as well as finding their asymptotes. So before we begin, we have to remind ourselves what a rational expression is. A rational expression is something such as y is equal to 3x plus 5. A rational function is when I have two rational expressions, one on top of the other. As an example, we have 4x plus 7 over 2x squared minus 8. That is a rational function because it has a polynomial function both in the numerator and in the denominator. Now, if we set our equation to be in an equivalent form as ax plus m over bx minus h plus k, then we can derive several truths about my rational function. First off, if we have both of them being to the same power, so in the numerator and the denominator are both equal to the first degree, in my example over here, notice that my denominator has a second degree in it. Therefore, it's not going to work exactly like what I'm going to show here. But if they are of the same degree, then that means there is going to be a vertical asymptote at h over b. H over b. So if we were to ignore that x squared there, I would have a vertical asymptote at 8 divided by 2, which is 4. The safer way to go about it, rather than just learning this equation, is to go ahead and set your equation equal to 0 and solve. That way you don't have to worry whether it has the same degree in the numerator and the denominator or if they're different. So as an example here, if I work this one out, if I set the 2x squared minus 8 equal to 0, I would then solve for x by adding 8 to both sides. So I have 2x squared is equal to 8. Dividing both sides by 2 gives me x squared equal to 4. And then taking the square root of 4 gives me a plus or minus 2 value. So I have zeros at plus or minus 2, which is going to indicate an asymptote at that location under certain conditions. The second thing I can derive from my general equation is that the horizontal asymptotes will be located in one of several spots depending on the type of rational expression or function that I have. It's going to be non-existent if the numerator has a greater degree than the denominator. So if I had something like 3x cubed plus 7 all over x minus 2, there is not going to be an asymptote for that one, a horizontal asymptote for that particular function. That one would have a vertical asymptote. It's going to be at y equals k if the numerator is of a lesser degree than the denominator, such as what we have right here. So in this example, my numerator degree is less than my denominator degree. Therefore, I will have a horizontal asymptote for the end behaviors that is equal to my k value, which in this case is the portion that shifts it up or down. In my example, that k value is an understood 0. So my horizontal asymptote would be at the location of y equals 0. And if we have a degree that is both the same in the numerator and in the denominator, such as 3x plus 7 over 3x minus 2, that means that we are going to have a horizontal asymptote at a over b. So if we take my coefficients of my x's and put them over each other just like they are in my original equation, that will give me my horizontal asymptote if we have an equal degree in both the numerator and the denominator. So let's try a couple of examples. Let's see if we can figure out where the asymptotes are in some of these functions. If f of x is equal to x squared over x plus 1, where are the asymptotes? I'm looking for both the horizontal and the vertical asymptotes. Go ahead and pause the video until you are ready to answer, and then you can start it up again. So we'll begin with the horizontal asymptote. It doesn't really matter which one you do first. I'm going to start with the horizontal asymptote. My degree of my numerator is greater than the degree of my denominator, which means I have no horizontal asymptote. For the vertical asymptote, I'm going to set my denominator equal to 0. So x plus 1 is equal to 0. If I subtract 1 from both sides, I get x is equal to negative 1. Therefore, I'm going to have a vertical asymptote at negative 1. If we were to graph it, which we'll talk about how to do that in just a few minutes, it would look like this. You'll notice that I don't have any horizontal asymptotes, but I do have a vertical asymptote right here, where it is x is equal to negative 1. Let's try f of x is equal to 3 over x squared minus 1. Again, pause the video until you're ready. In this particular case, I don't have a variable in my numerator, which means my denominator is greater of degree than my numerator's degree. Therefore, I am going to have an asymptote that is horizontal. Where is that horizontal asymptote going to be located? It is going to be located at y equals 0 because I have an understood plus 0 here off to the side. Now, as far as the vertical asymptote, I need to set my denominator equal to 0. So I have x squared minus 1 is equal to 0. Adding 1 to both sides give me x squared is equal to 1. And taking the square root of both sides, I get x is equal to plus or minus 1. I could also go through the process of reverse FOILing it, so factoring it into the two binomials, and then setting each of those binomials equal to 0. I would still get the plus or minus 1. This way is a little bit safer because you're less likely to forget about the plus and the minus. If we were to graph it, you will see the graph that is done. We do have two vertical asymptotes, one at negative 1, one at positive 1. And we do have a horizontal asymptote right here at y equals 0. You'll notice that as it goes toward the negative, as x nears negative infinity, y is getting closer and closer to that 0 value. As x is nearing positive infinity, the value of y is also nearing 0. Try f of x is equal to 2x plus 1 over x minus 3. Again, pause the video and come back when you're ready. Since my numerator and my denominator both have the same degree, that tells me that my asymptote horizontally is going to be located at a over b. So 2 over 1. In this case, 2 over 1 would be equal to 2. So I'm going to have a horizontal asymptote at 2. My vertical asymptote, if I set my denominator equal to 0, I have x minus 3 equal to 0, which means x would be equal to 3. A vertical asymptote at 3. Graphing it is what we're going to be looking at in the next piece here. So this is a good way to kind of usher in the next concept. So here's the basic steps that you need to take in order to graph, at least initially when we're learning, is indicate where the asymptotes are. That's why we went through the horizontal and the vertical asymptotes first. So you could figure those out. That's going to allow you to graph a little bit more quickly. And it's also going to allow you to see if things are crossing over, are they jumping, because you know there's an asymptote there. That means if you get values on both sides, you know you've jumped across some sort of asymptote and it doesn't actually cross over, you've jumped it. Second thing you're going to do is make a table of numbers, choosing values of x, finding the corresponding values for y, and then plot those points and connect all those points with a curve. Keeping in mind that you cannot go over asymptotes with your line, you would have to break it. So it's going to be discontinuous is the term that is used. So let's try one. Let's say we wanted to graph x cubed over x minus 1. So if I think about my horizontal and vertical asymptotes first, I'm then going to pick some values of x, plot those points, and then connect those points with a smooth curve. Go ahead and figure out the asymptotes. Pause the video. When you get done with the asymptotes, come back and we'll check those before we go to the next step. So since the degree of my numerator is greater than that of my denominator, it tells me that there are no horizontal asymptotes. However, I do have a vertical asymptote, and that vertical asymptote is located when x is equal to 1. If I were to plug in a 1 for my x value, I would get 0 in the denominator. So I do have a vertical asymptote at x equals 1. Horizontal asymptotes, none, because my degree in the numerator is greater than that in the denominator. So no worries about graphing the horizontal asymptotes. That brings us to the next section where we're going to plug in values of x and solve. I usually like to start near my asymptotes. If I have a vertical asymptote, that really helps. Choose some numbers. You might need to use numbers that are partials, such as a -1/2 or a +1/2 or 3.5 or 3 1/4, in order to get to see what is actually happening with your graph at the places near the asymptote. But go ahead and pause the video and plug in some numbers, graph it, and see how close you get to the real graph. So I'm going to begin by making a table of sorts. It's not going to look like a table up here. I'm just going to pick values of x and then write in what my value of y when we use that value of x. So if I plug in a -3, that would be -3 cubed. That gives me a -27. And then I'm going to divide by a -3 minus 1. Well, -3 minus 1 is a -4. So I have -27 divided by -4. A negative divided by a negative is positive. 27/4 gives me 6.75. So once I have that 6.75, I'm going to put a point at that location, -3, positive 6.75. My scale on my vertical is going by 2. My scale on my horizontal is just going by 1s. Now I'll pick another point. The next point that I chose was -2. When I plugged in a -2, -2 cubed gives me a -8. I have -2 minus 1 gives me -3. -8 divided by -3 is a positive 2 2/3 or 2.67. So at -2, 2.67, I plot my point there. A third point, as I get closer and closer to my asymptote, is -1. -1 cubed is -1. -1 minus 1 is a -2. So I have -1 over -2. That gives me a positive 1/2. So when x is -1, y is positive 1/2. If I move to 0, plugging in a 0, I get 0 in my numerator. I get -1 in my denominator. 0 divided by -1 is still 0. So 0, 0, my origin is now on my graph. Plugging in a 1/2, because I am getting closer to that asymptote, I want to know, am I shooting back up when I get to that asymptote, or am I shooting down as I get to the asymptote? So be careful about cutting things off too early. So for this one, I'm going to plug in a 0.5, a positive 0.5 or a positive 1/2. And that's going to give me a -1/4 as my output. So when x is equal to 1/2, y is equal to a -1/4. I'm going to now jump across my asymptote and use 1.5. When I plug in a 1.5 for my x, I get 6.75 for my y value. So we're right back up here at 6.75. When I plug in a 2, I get an 8 as my output, so I plot 2, 8. And then 3, 13.5. So when I plug in a 3, I get 13.5. At that point, I'm probably going to be off my graph if I plug in any more points, but you can certainly do that. If you have a calculator that will give you a table, that would be excellent. That gives you these numbers a lot faster, but you do need to know how to graph it without having a calculator. Now I need to connect my points with a smooth curve. It looks like this one is coming in from the top and probably going down toward the bottom. So I may want to pick yet another point really, really close to my asymptote of +1, like maybe a 0.9 or something like that if I were doing this graph. And I might pick some values really close to like 1.1 to give me an idea of where it's going on this side of my graph. If you do that, you end up indicating the direction of the graph, and it's going to look something like this. Let's try another one. Let's do x squared minus x minus 6 over x plus 1. This time I'm going to start out with my vertical asymptote and then my horizontal asymptote. So go ahead and pause the video, get those two pieces, and then come back. So my vertical asymptote is when the denominator is equal to 0, In order for that to be the case, x would have to be equal to -1. So I have a vertical asymptote at x equals -1. My numerator has a greater degree than my denominator, which tells me I do not have any horizontal asymptotes. So it's just that one vertical. On your graph paper, go ahead and put an asymptote, which is a dashed line, at -1. And now let's pick some points. Go ahead and pause the video, pick some points, draw your graph, and then come back and we'll see if you get the same answer that I did. So using points, if I make a table, or in my case, I'm just choosing points for x and coming up with a corresponding value of y, I get -8, -9.43. When I plug in a -5 for my x, I get -6 for my y. -3 for x gives me -3 for y. -2 for x gives me 0 for y, and so on. You can see the rest of those numbers. You do not have to have those exact same numbers, although you should if you have plugged in the same values that I did. But you can use other values. You just need to know how your graph is going to look by the time you get done. Now, if we plot all those points onto our graph paper, it's going to look something like this. You will notice that right here at -1, it does appear as though I have a vertical asymptote. This line is continuously going up, and it's going to get closer and closer to that value of 1, but never touch. This one on the right side is also going up as we go from left to right, and it comes from extremely close to the -1 value and goes off into infinity on the positive end. So I hope you got that one correct. Let's try another one. Let's go with graphing f of x is equal to the quantity of x plus 1 cubed over the quantity of x plus 2 squared. Once again, start off with figuring out your asymptotes. Pause the video and come back when you get that done. If you look at the vertical asymptote first, if I plug in a -2 for my x value, I will have a vertical asymptote. So x equals -2 is my vertical. My horizontal asymptote, I have a greater degree in the numerator than in the denominator. Therefore, there is no horizontal asymptote for this. Now, pause the video once again, plug in some values for x, find out what your corresponding values of y, draw your graph, and then come back and we'll see you have the same answer. These are the points that I chose when I was making my graph. I used 8 and got -9.53, a -5, -7.11, and so on. If we plot those various points, or the points that you chose, hopefully they still coincide with what our final graph is going to be. Our final graph looks something like this, kind of crazy. Right? On the left side of my vertical asymptote, again, my vertical asymptote was at -2, so right in here, I have just an up and down kind of image. On the right side of my asymptote, it goes up, starts to level out, and then shoots up again. Did yours look similar to mine? Hopefully it did. We're going to now go to using this in a real-life situation. Let's take a look at this example here. We've got a boat that travels upstream at R1 miles per hour. So we don't know the exact rate at which they are traveling, but we're just calling it R1. Returning, it traveled at a rate of R2 miles per hour. If the average speed is R equals 2R1 R2 over R1 plus R2, graph this equation if R2 is equal to 10 miles per hour. So what do you think we need to do first with this equation? I'll give you a moment to think about it. If you said substitute in for our R2 value, the positive 10, you are absolutely correct. That's exactly what we need to do. It's going to make things a little bit simpler. So in my numerator, I now have 2 times my R1. I just went ahead and called it R since we only have one R variable now. So 2R times the R2 value, which was 10. That gives me a total of 20R. In my denominator, I have R1, which again I just changed to the R, plus my R2 value, which is 10. Now, what is my degree of my numerator and what is my degree of my denominator? Well, the degree of my numerator is the same as the degree in my denominator. So what does that tell me about asymptotes? That tells me I now have a horizontal asymptote. Where is that horizontal asymptote located? That horizontal asymptote is going to be located at 20 over 1. My coefficient of my r term in the numerator divided by the coefficient of my r term in the denominator. 20 over 1 is equal to 20. So I have a horizontal asymptote at 20. What about a vertical asymptote? My vertical asymptote occurs where my denominator is equal to 0. So if I have a negative 10 for my r value, that is going to give me my vertical asymptote. Since this is a real-life situation, negative speed really doesn't make much sense. It would indicate perhaps going backwards, but in this particular scenario, there is no backwards. They are going up the river and they're traveling back down the river, so we didn't define one as positive or one as negative. So I can go ahead and say I can restrict my domain to be just positive values of x. My speed has to be a positive value. So r is going to be greater than or equal to 0 since those negative speeds are not possible to have. Now we're going to make a table of our numbers and try to plot the graph. I'll give you a moment. Go ahead and pause, see if you can get that table. If you made your table and you got some numbers, hopefully when you graphed it, your graph looks something like I have right here. I am just using the first quadrant of my graph because as we said, we restricted our domain to just positive values. So I'm just using positive values of r. So my graph is going to have this kind of curve. The faster my rate, the larger my capital R value is going to be. So my domain or value is greater than or equal to 0. My range is going to be values greater than or equal to 0, but less than 20. Remember, I do have an asymptote at 20 right here. So that means the highest I would need to make my graph is at this 20 line. It's never going to reach that value. It's just going to get closer and closer as we go out toward positive infinity on my x. Let's try this one. We have s is equal to 45x plus 25 all over x plus 1. That is used to determine the salaries for a company in thousands of dollars where x is the number of years an employee has worked there. So just like with the last one, this is a real life scenario, so we can't have negative years. I got to think about that. When we look at vertical and horizontal asymptotes, I'm going to start off with my vertical asymptote. Where do I find my vertical asymptote? When the denominator is equal to 0. And I'm going to find my horizontal asymptote. Go ahead and find those. Many of you probably already done it. X is equal to negative 1. That's going to be my vertical asymptote. Fortunately, I can't have negative values of years served. I can only go down to 0. So I don't even have to worry about my vertical asymptote because it's out of play, so to speak. My horizontal asymptote, though, is going to be at 45 over 1. So I have a horizontal asymptote at 45. Now to start graphing it. If I pick some values, plot those points, I'll get my graph. Go ahead and take a moment, pause the video, and do that. So if you've made your table, hopefully when you plotted those points, you come up with a graph that looks similar to what is on the screen. Once again, we can't really go into the negative values, even though my graph does show those negative values. I did not restrict it when I plugged it in, but I do understand that I can't get less than 0. And so this would be my graph. And so it's going to kind of taper off at the 45 mark. So the salary cannot go more than 45,000 based on this particular equation, no matter how many years you served with the company. As you serve with the company, it does start to grow very quickly, but then as you get past probably 7 or 8 years, it starts to really slow down. You're still getting raises, but not nearly the amount of raise that you got early on in your career at that particular company. So today what we've discussed was rational functions, where we have a rational expression in the numerator and in the denominator. We looked at finding the vertical asymptote. The vertical asymptote is located where your value in the denominator becomes 0. So you're going to take the expression that you have in your denominator, set it equal to 0, and then solve for that particular value of x. For the horizontal asymptotes, if your numerator is a greater degree than the denominator, you have no horizontal asymptote. If your degree in your numerator is equal to the degree in your denominator, you are indeed going to have a horizontal asymptote, and that horizontal asymptote is going to be at the location where your coefficient in your numerator divided by the coefficient in your denominator. If your degree in your denominator is greater than the degree in your numerator, then you're going to have a horizontal asymptote located where your y value is equal to the k value. That's the portion that's outside the fractional portion where it's shifting the whole graph either up or down. In the second half of the lesson, we looked at how to graph. You're going to start out by finding your horizontal and vertical asymptotes, if there are any. Then you're going to plot points, choosing values for x, finding the corresponding value of y, connect those points with a smooth curve, and at that point you are done.